Hi, folks. Welcome to part two of your Module 1 demonstration. I've taken a little break, got some more coffee. You may need some too. Buckle in here for part two. Just to recap, in part one of our video, we talked about the basics of getting started in R. We talked about the R environment, the input-output relationship, as well as how to open an R Markdown file, which we now have open. We talked a little bit about what that was. We talked about packages, how to install and load our packages. So now we're getting into the nitty gritty, the part where we really start to do some of the tasks that I find I do all the time as someone who analyzes data a lot. So first step, which is not to be underestimated, is getting the data into R, loading in the data. And thankfully, RStudio has made this, I think, extremely easy. If you remember in part one of the video, I talked about this little file pane down here. We have files, plots, packages, etc. This file plot makes it very easy to import data into R. So here I've navigated to week one, where I have all the materials for week one. And I want to load in this data set called descriptive_gss.dta. You may be asking, what is a DTA file? Great question. DTA is the file extension for Stata files. So just like SAS is .sav, Excel is .xls, right, or .xlsx. We have comma separated variable files, CSV. We have SAS files, which I think are .sas. I can't remember. So .dta is an example of a Stata file. And what is cool about RStudio is it automatically recognizes all of these different file types. And so I can go here to descriptive_gts. I can click on it, and I have two options. One, to view the file. That would be like, for example, if it was an Excel file, it would open it in Excel for me. Or I can actually import the data set, which is really handy. So if you click that button, you get this new window that says import statistical data. And notice it gives you a URL here. So this is the file that I clicked on. But if I want to click on a different file, I can just click update and I can pick a different file. And then I get a really nice preview of the data. So it just takes the first 50 entries in this data set, and it shows me a set of the variables. So these are the variables. And notice these variables have labels. The label is the part down here. So this variable is called ID. The label says respondent ID number. So all these labels and names were created in Stata. So if you have, for example, an SPSS file that you're working with, and it has labels, those labels will be recognized by R, which is really cool. It automatically kind of recognizes that. So a few things I recommend. So down here where it says import options, I always like to give my data sets or my data frames as simple a name as possible. So I'm just going to call this GSS. And GSS, by the way, stands for the General Social Survey. So this is a data set that is collected annually by the National Opinion Research Center, NORC, which is a think tank affiliated with the University of Chicago. And every year they conduct a telephone survey, now more cell phones than landlines, where they call and ask people their opinions and their attitudes about a lot of different topics. And so it's sort of a general social science survey. There are some questions about education, which is kind of interesting. They also ask about political views. They ask about work. They ask about leisure time. There's lots of interesting data in this survey. And it's actually, a lot of it is publicly available, which is pretty cool. So anyway, I'm going to call this this data set GSS. I'm going to click away a little bit. And notice down here, this says code preview. So if you wanted, it's actually showing you, if you, next time you do this, you don't want to go through the task of clicking import and then clicking import here and importing this data set into R. If you want to do it all by code, which is pretty nice, right? It saves the clicks. Some people like to save the clicks. You can just copy and paste this code preview into your R Markdown file in one of those little R windows. And it will automatically go and grab this data set the next time you want to, which is really handy. And a very cool function. And notice it is using a different library. We've already loaded this one. It's called Library Haven. Haven is the package that is what I talked about, which is the Rosetta Stone, which kind of allows you to translate between different data types. So that's the Haven package. And that is the package that has this function, which is read underscore DTA. So read functions input data, write functions export data. So you can take data in and you can put data out in all sorts of formats. And then, so the function really is just read underscore DTA, because this is a Stata file. And then in quotation marks here, this is the path, right? This is the path to the file, and then the file itself. Okay. So I'm just gonna click import just to import this. And notice the data also the software also automatically ran this view command, view GSS. And all this did is it popped open this data set, this new data set, so that I could kind of scroll around and look at it. And this is very much like the data view in SPSS. So just like in SPSS, you can kind of scroll around. Now you can't edit anything in here. That has to be done kind of manually. But you can observe all the variables, and you can see, so we have showing 29 to 56 of a total of, we have 2,765 entries. So those are observations. I typically call those observations, which means we have 2,765 people here, and 16 total columns. Columns are the variable names. Okay, so that's an important distinction to keep straight in sort of our language. Rows are observations, columns are variables. Rows, columns. That's sort of the fundamental, they call it a tidy structure of almost all data sets that we work with in stats. We have rows and we have columns. Okay, and if we look in our environment, we actually have a new component here. In addition to our values that we learned in part one, we now have a data set called GSS, and it's 2,765 observations of 16 variables. And if I click on this, I have to move my little window here, but if I come here and I click on this, notice it turns to a little pointy finger. I can actually click on that, and that's the same as running the view command, and the data set actually pops right up for me again, which is really handy. Okay, so that's this set of code right here that I just ran on lines 18 through 24. So I input the data, I assigned it. Remember, here's that assignment operator. I'm pointing to the name I want to give it. So I have a new data set called GSS. I ran the view command. And then, so that all that is very easy to do, and it's highly recommended to get a sense of your data. The other thing that I really recommend is the glimpse command. And this is another one that comes from the tidyverse. And so I have already ran the first two parts of this command. I already have my data set and I've already looked at it. So if I just want to run one little line, I don't actually have to push this green play button. I can just hold down the control and return buttons, and it runs just one line. So control on your keyboard and enter runs a single line. You can also highlight this, right? So it's highlighted, and then you can click run selected line. So there's lots of different shortcuts. So the glimpse command. Okay, so why do I love the glimpse command? Well, you can only find out so much about a data set by viewing it in that variable view command, in that data view command. You also need to have a sense of the structure of the data. How is it coded? What kind of data are in this data set? Is it mostly numeric data? Is it string data, text? Is it logical, true, false? Do we have categorical variables? Do we have continuous variables? And that is sometimes hard to tell in data view, but might be easier in variable view. So glimpse is basically the equivalent of variable view in SPSS, where you get a sense of some of the properties of the data. And so here you get a nice summary Again, we get the number of rows and columns. That gives us the dimensions of our data set, how many people and how many variables. And then we also get information about each variable. So here, these little dollar signs going down the side here, each row here is a different variable, and it's giving you a summary of that variable. So here's the variable ID. Inside the carets here, that is the type of data, the data type that ID are, and it's type double, DBL. And double just basically means it's a number. You can have numeric data, you can have character data, which is letters and numbers. You can have true, false, that's called a logical. And you can have what are called factors, and those are categorical variables. But here, R has just assumed, R basically takes a look at your data and tries to figure out what it is. And its best guess here is that all of these data are numeric. Now, that's not necessarily true. Some of these, for example, this variable marital status we will see is not a continuous variable. It's categorical. It's different types, different statuses, single, married, widowed, divorced, that have to do with marital status. So sometimes R doesn't make the right call and you have to go in, and we'll learn how to do that in later weeks, how to kind of recode things into what they need to be in order for it to work for us. And so then after that, so notice some of these are also double plus label. And label just means there's some label that was attached to it in other software. Maybe it's a description, maybe it's different categories. I'll show you how to explore that more. And next to the type of data, which is in between the carets, are just a sample of about the first 10 entries in the data set. So this is to give you a sense of what the data actually look like without having to click view and actually kind of scroll through things. So this just gives us a sense of what the data look like, what the values are, and the values here are separated by commas. NA, you might be asking, that is our language for missing. NA, so NA is not applicable, and it is in R, it means it is system missing. So it means that that cell is essentially empty. There is not a data point for that particular variable for that person. And we'll actually talk about what to do about missing data in a later unit in this course, which is actually very fun. All right, so that is loading in the data and exploring the data structure. Very important steps. I do it with every data set I open pretty much, unless it's a data set I know very well. We can get a little more fine-grained here, and we can actually explore some of those variable labels I talked about. So a lot of these have labels. So the command here to do that is a function. Anytime you see a string of words and then parentheses, you're running a function, which is just it's a little helper program that runs something in the background for you. So this str function means structure. And what that does is it gives you the structure of a particular variable. And that can also mean it gives us the label. So it gives us more information about that variable. So I'm going to run, do Control Enter again, and I'm just going to run the structure for this first variable. And notice in parentheses, I have GSS, which is the name of my data set, and $, which indexes one of the variables. So it says look in GSS. And then within GSS, look at the marital variable. Now, the cool thing about R, I'm going to delete this. I know this is a little different than on yours, but R has what's called predictive typing, or actually RStudio. So it's going to try to help you. So watch what happens when I start typing structure. STR, the first thing that pops up is the command I need, which is the structure command. It even gives me a little help. It says, compactly display the internal structure of an R object, a diagnostic function, and an alternative to summary. So that's exactly what I want. So I'm going to hit enter. So it gave me the command, and then it gives me a little helper here. It says you need to put an object here. So GSS is my object. And notice there, GSS pops right up and is recognized. So it sees that GSS is in my environment. So I'm going to click that. And then this is cool. Once you've selected an object, type in $, and it'll actually pull up all of the variables in that data set for you, and you can pick it that way. So I'm gonna go down to marital and I'm gonna hit enter. So predictive typing, really, really cool and handy way to get a sense of this. So here's the structure. It has a label. Here's the label of this variable. The variable label is marital status. Not super helpful. Here's the format. This is for Stata. If I ever need to go back to Stata, this is the format it's in. And then here are the labels. This is very helpful. So there are essentially, there are a series of named numbers. So I have 1, 2, 3, 4, 5, and 9. And the categories stand for married, widowed, divorced, separated, and then there are 2 other categories, which I can dig into if I needed to. Again, the code book would help me with that too if I wanted to find that out. To find more information about that. So that gives me a sense of what these variable labels are. I can do the same thing with this variable GSS and then respondent's sex. So here, the variables here, they're all ones. And so there are only 2 labels here, 1 and 2. So the labels here are male and female. This is a bit old. I think this is from 2012. So I think the GSS now has a much more inclusive measure of gender or respondent sex. But in this case, these are the 2 categories that we have. And then we have STR childs. And this is the number of children. And here again, we have, this is a named number. So this basically is, if it's 0, the respondent has no children, 1, 1, 2, 2, 3, 3. So this is basically numeric. This would not be sort of a classical categorical variable, but it's good to know. All right, so that's the structure or STR function. All right, so let's play with a couple more basic exploratory tools. One thing that we always want to do is we want to get descriptive statistics. And there are lots of ways to get descriptive statistics in R. You can type mean just to get the mean of a variable or standard deviation. But there are lots of packages and functions that make that much easier and put things in a much more organized format. So I recommend this function called describe that is found in the psych package. The psych package is very useful. I load it up all the time. So to run this function, we just say describe, and then in parentheses, GSS. And then I'm going to put, this is called an option on a function. So I put fast equals true. And what this is going to do is it's going to give me a smaller list of descriptive statistics. Normally, this function gives you like 20 different descriptive statistics, which you don't really need for basic exploration, but I really like just saying fast equals true. And so you get a nice summary here. So here are my variables. These are the first 10. And if I click over here, I can get the next 6. And here we have an N, mean, standard deviation, min, max, range, and standard error. So pretty concise version here. So we get the mean, we get the standard deviation, we get the minimum value, the maximum value, the range is the difference between the 2. And then the standard error is, I think, the standard deviation divided by the square root of the sample size, which we don't use a ton, to be honest. It's more useful in things like regression. But the other variables here are extremely useful. Now, notice, since R thinks that all of these things are numeric, you get some means and some descriptive statistics that don't make much sense. For example, it wouldn't make sense to do descriptive statistics for an ID variable. Right, an ID variable doesn't really have any meaning other than, your respondent number 553254, right? Like it doesn't have a meaning. Same thing with marital status. That one, since it's categorical, is not so useful. I'll show you in later weeks how to convert those other variables out so that they're not included in a summary like this. But other things like age and a number of children, so those are more useful ways of getting descriptive summaries. For those categorical variables, we can use something called the table command. And that is a really nice, it basically gives you cross tabulations. And for example, here I'm asking for a table, a cross tabulation of the marital variable. And that's a nice summary. So I have 1,200 people who are in category 1, which I think was maybe married, what are the categories again? Let's run this again. Category 1 was, yeah, married, widowed, divorced, separated, 1, 2, 3, 4. So married, widowed, divorced, separated, and I'm not sure what category 5 is. I assume it must be single, right? I think that's one category that's probably missing. So that's a breakdown of that variable. There's also table GSS sex, that gives you the breakdown there. And then here's the child's variable. So these are the number. So here are the label values. Here are the actual numeric values, and these are the number of respondents that are in each category. So it's just a little cross tabulation to figure out what things look like. All right. So one more thing I'll show you, I know I've thrown a lot at you, we've covered a lot of stuff in these videos, is a histogram. I love histograms. I think they are, I describe it as a quick and dirty way to explore continuous values. They're very important because they give you a sense of the distribution of the variable. And that often has implications for the kinds of analysis that we can actually do on the variable. So it's very useful. So I'm going to show you how to use the ggplot package, or ggplot2. There we go. Sorry, I'm editing my own thing. Which is a really powerful and versatile way of creating all sorts of different plots. Now, are there simpler and quicker ways just to make a histogram? Yes. Remember, there are a million ways to do things in R. But what's cool about ggplot is it's so extendable and functional. You can make virtually any kind of different plot using ggplot. And so I like to teach it because I think it's kind of a framework, and you can scaffold so many different cool types of visualization on there. So the command for ggplot is this. So basically you have a base command that tells ggplot what the data are and what the variables you want to plot are. And then you add on to that base command what type of plot you actually want to create. And that's done basically like addition with plus signs. So here, I want to create a ggplot. The data are in GSS, so it's going to look at my data set. And then this mapping is just the way it thinks about that standard. You have to put that in the command. But inside this mapping equals AES or aesthetic, you just need to tell it what goes on the x-axis, what goes on the y-axis. And in this case, since we're doing a histogram only basically has the y-axis is a count. It's the number of people in each category. And the x-axis is actually the name of the variable. And so here I'm going to put the variable child's there. So I'm going to do a histogram of the child's variable, and then and close that up. So you can, if you want to make another histogram, you can just swap out this name for another variable in this data set, and it'll pop out another histogram. And then geom bar is just they're called geoms. It's like the tool for creating the specific type of plot. And so a bar plot is what we're making. So I can press the play button here, and there we get this very nice histogram. So here we have a count. So this is the number of people. About 800 people had 0 children. 5 foursome had 1. 602, 3, 4, 5, 6, 7, and 8 all the way across. So this is a breakdown. So it's telling us here, it thinks that this variable is continuous. That's right. In this case, it is basically continuous. And 5 rows were removed containing non-finite values. So those are missing. So 5 people were missing from this particular question. And so they were removed from the plot. All right, so that's just a nice basic default ggplot of this. And so here's a fancier version, like for publication, you can clean this up a little bit. You can add some titles and labels and really make it look pretty. So the top is exactly the same, the top line here, but then I've just added a plus sign, and I've added this command labs for labels. And I've given it a title. So this is the title, and notice it goes in quotation marks. and then a comma, and then I gave the x-axis a name because childs looks kind of weird, so I'm going to put number of children, and then a comma, and I even gave this a caption. So data from the General Social Survey, and then n equals 2,765. So these are the kinds of things you'd want in a plot that's going to be presented, as opposed to just kind of for your own exploration. And so I'm going to run that. And there's a much nicer version of this plot, which is very, looks good and is useful and has all the different labels and things that I need. Okay. All right. So, phew, a lot covered in this first lesson, right? So let's go back and do a quick recap. In this part 2 of the video, first we talked about how to get data into R. And RStudio has made this 1,000 times easier. It's basically point and click, but you can also use the code as well. We use the read_DTA function, which reads Stata files. We learned about the view command, which pops up the actual data set to look at. And we learned about glimpse, which gives us more details about the variables. We explored the structure of several variables and got a better feeling for the labeling scheme and how things were broken out. We learned how to do some basic descriptive statistics using the describe function that comes from the psych package. And we learned about how to do some basic tabulations with the table command to see how things were broken up. And then we learned how to do a basic and fancier version of a histogram or a bar plot using the ggplot package. So lots of fun stuff here. Again, we do not have to be experts in all this at once. So if you're feeling like, wow, there's so much going on, so many packages, lots of different things, 80 to 90% of what we covered this week, we will use next week and the week after and the week after. So the idea is that we're building slowly and giving you gradual experience with these new functions so that over time you become more comfortable with them. So stick with it, and I hope that this makes sense, and I hope you have a good week.